welcome everybody. It's great to see everybody here. So good evening, good morning, wherever you are. I am broadcasting from Saarbrücken in Germany. Welcome to the Society's inaugural Cosmos lecture. As a professional association devoted to supporting, organizing, and conducting scholarship around the subject of UAP, a controversial subject to be sure, the Society for UAP Studies is absolutely committed to a single principle, the pursuit of truth through evidence-based research and open, rational dialogue, even if it may at some points be contentious. Indeed, the Society welcomes wholeheartedly dispute, disagreement, and difference in opinion, assumption, and argumentation. We might say that this is finally the enduring essence of science itself. We must never forget that it is not a body of final doctrines, but as sociologist Marcello Ciuzzi, following the philosopher of science Mario Bonga, always pointed out, it is above all method of observation, experimentation, and explanation by hypothesis. The understanding of science, this understanding of science allows it to maintain an historical dimension, subject always to change in time, since it is nature that gradually teaches us as we probe with concept and instrument. We who remain eternally fallible creatures, ever learning the apparent structures of nature that our concepts and experience disclose, which also change. The name of this distinguished lecture series refers us to the work of Carl Sagan. Sagan was a complicated figure, to be sure, but despite Sagan's often dogged criticism that bordered on zealotry when it came to the subject of what was in his time called UFOs, Sagan was ultimately committed to the spirit of science as process and method. Indeed, early on, before the attempt to study these phenomena scientifically got caught in a long quagmire of dismissal, ridicule, and perpetual unwillingness to fund its research, Sagan was open to just that, the science that would and could produce sound data from which we might reason to more substantial and more certain conclusions regarding the nature and origins of these many puzzling phenomena that we call UAP now. Sagan would have been 90 years old this November, and it has taken almost that time to get to the point today where a new generation of scientists and researchers have the courage and some of the funding to take up the mantle of cautious but rigorous science to study what are now called, rightly in my view, unidentified aerial and anomalous phenomena. It is an arduous path, to be sure, requiring a lot of preliminary conceptual and technical work in order to stabilize the foundations for a systematic observational science of the phenomena that escapes the trap of inconclusive forensic cold case chases that has plagued so-called ufology for almost 90 years. Likely the primary target, of course, of Sagan's vociferous criticisms of UFO research and researchers. Today we are joined by one scientist whom we might say stands in the great SETI legacy, trailblazed by Carl Sagan himself. Joining us today is Professor of Astrophysics and Astrobiology researcher Dr. Adam Frank. Our distinguished colleague, Dr. Beatrice Villarroel, herself a pioneering and courageous young scientist, bringing the rigors of systematic observational science to bear on the UAP question, will introduce our distinguished speaker for us today. Beatrice, please.
It's a real honor to introduce Professor Adam Frank, who is a Helen and Fred Gowen Chair Professor of Astrophysics at the University of Rochester, and has done a huge impact in stellar evolution, and is also very prominent now in the technosignature searches. So Professor Frank has a PhD in physics from 1992, and he actually has a number of awards. For example, the Carl Sagan Medal in 2021. He has also the Joseph Burton Award from the American Physical Society in 2020, and his book got among the top 10 science books in Forbes 2021. Congratulations. And he currently has a grant from the really cool Templeton Foundation, which I think is super, super cool. And also another grant to work with technosignatures. And Adam has written a book called The Little Book of Aliens, Everything You Need to Know About Alien Life in the Universe. And it's one of these books that when you meet new people or friends, they always ask, have you read this book, The Little Book of Aliens? So I just want to welcome Professor Frank, and I leave the word to you.
Thank you. Okay, so Michael, it was great to hear. You know, I've been somewhat aware of what you guys do, and I think it's awesome what you just read out. So my talk today is going to be, you know, sort of very popular level, hopefully entertaining as well. At the end, you may not want to ever talk to me again, but we'll see, because you know, my talk is very much based in my skepticism about UFOs and UAPs having anything to do with aliens. But as I've said, like, the only way to really know is to do the science. So I'm like, in some sense, after you listen to this talk, you'll get an idea of somebody that, you know, you're going to need to convince more as we go along. So I'm going to, you know, as you guys try and do what you're trying to do, which I totally respect, which is to have a full agnostic, open-ended study of UAPs. But I want to sort of raise a bunch of issues and just talk in general about this is just really my perspective on it, for, you know, what it's worth. Okay, so first a little bit of personal history, what inspired me to think about alien life. Right, what do we do? It's Carl Sagan's everywhere. It's amazing in my life how often Carl Sagan, no matter what I'm studying, Carl Sagan shows up. My previous book, before The Little Book of Aliens, was about the astrobiology of the Anthropocene, where I was actually trying to look at climate change sort of from an astrobiological perspective. And the number of times Carl Sagan showed up in the research I did for that book, including, you know, I did a whole section on the Gaia hypothesis, where you think, like, what does Carl Sagan have to do with this? He was actually in the office. He shared an office with James Lovelock the day that James Lovelock came up with the fundamental insight into how atmospheres could be detectors of life. So it's just like, what was he doing there? And then his ex-wife, Lynn Margulis, ended up being, you know, working with Lovelock. So it's just, you know, Carl Sagan, when I was a kid reading his books, I was already into astronomy, but he's the one who really made me want to write about astronomy for a popular audience. But his whole style is really what inspired me. But then what else inspired me? Well, Captain James Kirk. Science fiction, you know, in general, was a huge part of I went into astronomy because Strange New Worlds. I was always interested in the idea of life in the universe as being, you know, the foundational question. So science fiction played a huge role for me. You know, I wanted to sort of emphasize this because one of the most interesting things about the work we're involved in with technosignatures, and it's going to relate to UAPs if you think, you know, if there's any argument about that UAPs are related to what I'm going to call exotechnology, is that, you know, one of the great things about science fiction, and this movie in particular, if you've never seen it, you should watch it, Forbidden Planet, like mid-1950s. It's arguably one of the greatest science fiction films ever made, because it's kind of it's like a standard 1950s pulp science fiction with, you know, sort of the saucer-shaped spacecraft, of course, the robot, you know, the scantily clad, you know, young woman, all the stuff that's was in all of those stories. And yet it's also a very intelligent exploration of the fate of civilizations, the fate of high-tech civilizations, which, if you want to think about technosignatures, if you want to think about life, intelligent life in the universe, you have to actually encounter that idea of what happens to civilizations over long periods of time. So, you know, it's very much shaped by science fiction, and I still am. I think, you know, some of the best science fiction, I think, does a great job of informing the possibilities for life in the universe. So now when it comes to UFOs and me, you know, when I was growing up, I certainly read lots of stuff about UFOs, and I was, you know, really taken by it, you know. And, you know, this book, now obviously this isn't UFOs, but it was related. But, you know, Chariots of the Gods, I'm sure you guys are familiar with it. You know, this was when I was, I don't know, like 12, 13, 14, I was reading this, and I just found it so convincing, and I was so into it. My poor father had to listen to me go on and on. You know, my dad is the one who turned me on to science fiction. I can just still see his eyes rolling as I said, "We've been visited." And in particular, one of the stories or one of the accounts, one of his, so-called scientific investigations was of the Easter Island with the giant statues and the whole argument about like why, there's, as you can see, there's no trees on Easter Island. How is it possible that these giant stone heads were moved around? Of course, the only way it could be was aliens. I was really taken by this idea. It seemed so rational as an explanation. And then a couple years later, I was sitting down watching PBS Nova, right? That was the only science program back then in the mid 1970s. And this came on, The Case of Ancient Astronauts, which went through not everyone, but most of von Daniken's case studies, and then actually talked to the scientists who studied it. Went to Easter Island, went to the Nazca Plain where those drawings, those Earth drawings are, and talked to the scientists who've been living with these phenomena for years, and they all had accounts, really amazing accounts of how these phenomena, what these artifacts were that had nothing to do with ancient aliens. And so in particular, the one that made an impression on me was Easter Island, was that, oh yeah, there were a lot of trees there, but the human beings cut them down to move the stone heads, right? So it was an example, rather than a story of ancient aliens, what I got a story was of human knuckleheadedness. And this made a huge impression on me because I was, raised in New Jersey, and there is nothing worse if you're from Jersey than being a sucker, than being a mark, being taken in. And this really burned me hard. I really felt I'd been lied to by von Daniken. And that burned a kind of, and then, along with reading Carl Sagan, this idea of, sort of having a really hard-nosed skepticism about anybody telling you anything that's extraordinary, right? Because this goes to Carl Sagan's famous dictum about extraordinary claims require extraordinary evidence. So my current stance now is that, just to be clear as we start, is that, it's great that the pilots are, we can move away from, people who see things should be able to report what they see, especially people who, are in positions where, the phenomena may actually, be dangerous for them, right? So pilots should not be stigmatized when it comes to reporting UAPs. And I am completely open to a fully public, fully transparent, and fully agnostic, and that's really the important thing, scientific investigation of UAPs for lots of reasons, right? One reason is it's the only way you're ever going to find out what's going on. And second of all is that this is something the public really cares about for, historical reasons. We have a huge amount of science denial in the world, which is very, very dangerous. We have to have a shared reality that we're living in to have democratic self-governance. And this would be a great place to show people how science works. Most people don't know how science, as someone who's been, fighting climate denial as a popularizer for, decades now, I understand how actually little contact people have with the actual process of science. This would be a great way to show them how science works. But I see no data conforming to the rigorous standards of evidence science requires that, oops, little typo there, that in any way links UFOs or UAPs to exotechnologies, i.e. aliens. So that's where I'm coming from. All right, so let me talk a little bit about my skepticism about UFOs and UAPs and the data that exists. So the first one is personal testimony, right? So much of UFO and UAP, the arguments for it come from personal testimony. And as any cop or prosecutor will tell you, eyewitness testimony is the worst kind of testimony. It has been shown numerous times that even trained observers, so this is the thing about the Navy pilots, and I have absolute respect for the Navy pilots, and I'm glad they can that we remove the stigma of them reporting, because it is in some way what points you to something. But the idea that we can use the personal testimony in any way as sort of scientific evidence, I think is just really flawed, because as it's been shown over and over again that once something extraordinary is happening, or once something that you feel is extraordinary, something you haven't seen before, or you're caught up in excitement, then your ability, the link between your testimony and objective reality is actually gets so blurred, right? So a personal testimony is not an account of what happened. It's an account of the personal experience of somebody, which is now also, as time goes on, becomes modified and modified. And, you guys are all aware of this. There's these famous experiments where, they ask somebody, hey, could you count up the number of, how many times the basketball has been passed back and forth by people in white t-shirts. And they won't even notice, the observers won't even notice the gorilla walking through who actually waves. But it's just this general idea that, if a giant octopus appears in the sky, having a pilot, or having me, report on it, there's really not going to be all that much difference in many ways, right? In terms of like the idea of trained observers, something that is seen as being amazing, something out of the ordinary, then everybody's going to have is going to have very colored responses. Okay. The images in general, over my time when I've written about this, people are always sending me images. What about this? What about that? And in general, it's a lifetime of fuzzy blob images, which is kind of remarkable. So I always like to show this photo. This is an image from the YouTube pilot, who it really looks to me like he was literally, that's his helmet, right? That he's literally holding up his cell phone taking this picture. And the clarity of this image, where you can see the Chinese spy balloon, and if you zoom in, you can make out the rivets on the solar panels on the payload, the hanging payload, and there's this sense of like, well, if UAPs if the sky was full of things we didn't understand, why wouldn't we have zillions of pictures like this? And instead, it's almost always fuzzy blob images. So this has always really contributed to one of the things that I just don't feel like there's the data there to drive, especially the link to anything exotechnology. I think there's an argument to make something's going on, but what it is and whether it's linked to exotechnology is where my skepticism comes. The second is that, again, when people talk about radar, often what you have is accounts of a radar operator saying, I see something. You rarely get the actual radar data itself. And this is problematic because, as I'm going to talk about, science functions when it has access to the data taking equipment. Because data, any data taking equipment can be can produce results that are difficult to understand in a wide variety of ways. And so when it comes to the radar, especially with the stuff that happened, with the videos and that came out, and the reports of radar, I highly recommend following Dr. Phil Metzger, who I think just is very clear on this. And one of the interesting things about Dr. Metzger is that he worked for a long time with the NASA space shuttle program with the radars. And he did I wish I could find it here, he did a long post one time about all the kinds of ways that the radar was spoofed, that they would see ghosts and shadows in the radar, things they couldn't understand. And it took an enormous amount of work to always dig through and figure out, okay, what was going on with the radar here? So, I think that's something that really you got to keep in mind. And it's one of the reasons also why still I'm not really driven very hard by the data what drives my current skepticism. And then finally, there's kind of just what I call the highbeam argument, which is, kind of just when we, any account of a phenomena, requires some kind of consistent, coherent story, a narrative about its occurrence. And one of the most amazing things to me about UFOs and UAPs, if somebody wants to draw a conclusion that these are related to exotechnology, is that, why aren't they landing on the White House lawn? If somebody's visiting us, if we're being visited by technology, why isn't it just clear? Why can't you just see it? What always happens is that somebody sees something, there's lights in the sky, and then they disappear, you see it for a while and then it disappears. So it's always like they, if it's exotechnology, they don't want us to see them, but they're really bad at that. They're really bad at not being detected. So I call that the high beam argument because, UFOs are always, I saw lights in the sky. Well, if they don't want to be seen, turn off the lights. What's the problem? They can't find the switch. And this leads to a whole idea about sort of the consistency and coherence about what we think if this was exotechnology, what we think it might be. What's actually going on? Are they probes? Are they Bracewell probes? Are they actually visiting, with the actual intelligence, biological intelligence, the pilots in them? So, okay. So these are in general what leads to my, and there's often this argument that like, oh, scientists don't care. They don't want to listen. They don't want to, they're closed-minded. I just wanted to point out this was the NASA UAP panel, right? That did the work on and I know a number of the people on these. I've worked with a number of the people on this. And some of them, I've published papers on, including a paper about whether or not planets can be intelligent, right? Which is a pretty radical idea. Pretty out there speculative idea. So it's not like, at least some of the people on here are unfamiliar with or unwilling to go to, kind of out there places in their reasoning. But, in talking with them, and I think the results of the panel showed that, like, as of yet, there's still nothing that is going to drive most scientists be like, oh, I've got to study this. I've got to study this. So I think, and now that may come out of the work you guys are doing, as if you could really get some good data. That could be something that you could see minds being changed. But as of right now, these people looked at the data that was there, and there's still not something that's driving lots of scientists, including scientists who are willing to go out there speculating wise to like say like, oh my God, this really something that needs to be done here. And this is captured by, a couple of times with the different reports recently. Where they've been doing investigation, where it's, and this is pretty much what all the reports have found throughout time, is that, most UAP sightings have conventional explanations. That you can find some explanations. So the things I found when I look around is with the modern stuff, the stuff that's been coming out of the recent reports since 2017, is still, greater than 94% or greater of all UAP and UFO and UAP sightings can be explained. So what that means is the sky is not full of unexplained things, right? It's not like we're just like, oh my God, every day there's just things happening in the sky that we don't understand. So having said that though, one of the things that actually led me to my, slightly more open view of this is this great paper by James McDonald, Science in Default. And this, a couple of members of the NASA project, of the NASA team that I'm the principal investigator of, pointed me to this paper. And James McDonald was a very well-respected, I'm sure you guys all know this, very well-respected atmospheric researcher who got interested in UFOs and UAPs. And he in particular was not very happy with the quality of the reports that have been done, particularly the Condon report. And he went back and for that small fraction of cases that didn't have explanations, he went back and did what the Condon report people hadn't done. He went back and interviewed the people who were involved. And the stories in this paper are pretty hair-raising, right? On the back of your neck. There's definitely things in these stories that are like, wow, that's amazing. Now, again, there's not much anybody can do with that other than, oh, here's some stories, here's some personal testimony. But it does point to the fact that there are some of these cases that are, certainly, you're gonna have to push harder to try and find what the explanation was. But again, as was said, these are cold cases and there's nothing you can do with them. But it did, this made an impression on me. Okay, and this brings us to the most important part when I talk to the public about this idea of standards of evidence, the importance of standards of evidence, which, as I like to say, is the most boring and most important subject ever. And standards of evidence are basically methods for linking a claim to data that supports that claim. Like, what is the standard that says, oh, this is a good, good link? And as you guys know, UFOlogy has been terrible with this. It's just, like in the book, I covered the Roswell stuff, which was, evidence is anybody anywhere who ever says that they, were around. Like, even, your uncle's hairdresser's cousin's, nephew's brother who said he knew somebody who was near Roswell when the ship crashed. And you guys know this, and so I don't really have to tell you this. But that's, the problem is the getting people to understand what standards of evidence mean. And it's taken us 400 years of scientific practice to work these out. And so the most important thing always to, for people to understand is scientists are mean to each other. we are brutal to each other. Like, if somebody stands up and has data and then wants to make a claim, even if it's just something within the confines of, normal science, some claim about, a stealth behavior of a M dwarf star, we'll rip each other to shreds, because that's our job is to hold each other to the highest standards. And we're not nice about it. I mean, hopefully we're polite, but if you're going to stand up and make a claim about some data that you have supporting, a claim, the more extraordinary that claim is, the more you should expect. You should go in there being ready to be torn apart. And so you better have your game face on, and you better know what your data says before you go in there. And the best case of this is Adam Rees. Adam Rees is the won a Nobel Prize for his discovery of what is now we think is dark energy. What he discovered was the accelerating universe. And I did an interview with him once. And I said, Adam, what was it like that moment? Because he was a graduate student. What was it like in that moment as a graduate student when you're looking at your data and you're like, oh my God, this data proves the exact opposite of what everybody for 30 years has thought, which was that the universe was decelerating due to the effect of gravity. In fact, it was accelerating. And he said, his response, I'll never forget it. He said he was terrified. He felt a pit in his stomach. And you're like, well, come on, you're about to win the Nobel Prize. And because he knew that he was going to have to stand up in front of the smartest people in the world, who knew their stuff inside and out, who had the fastest minds, and he was going to have to justify his data. The thing here on the right, was his data. And he was going to have to defend everything about his data because he was going to be met with profound skepticism. So that is what should be expected. That is holding to these standards of evidence is exactly that kind of fear, knowing that you're going to encounter that and being willing to encounter that. Okay, so let me just go through this a little bit from my view of what these standards of evidence are about. A few different important pieces. So the first one is you got to know your instruments, right? So for example, the JWST, if my colleagues and I were to say that we found evidence of a technosignature, in a spectral imprint of, by looking at a spectral line that of light from a star that had passed through a planetary atmosphere. People are going to ask us, the first thing they're going to ask us is did we use JWST correctly, right? Because we know everything about that instrument. We know how it behaves when it's at 30 degrees Kelvin, and we know how it behaves when it's 50 degrees Kelvin. We know how it behaves at this wavelength, and we know how it behaves at a wavelength that's twice as large as that. You have to know every aspect of your instrument. You have to be fully characterized before you even go and take data. Then the next thing is, okay, you're going to take data. What's your plan, right? So this is what I'm showing here. This is the Kepler data field. And what you can see here, all the different dots correspond to observations where a planet was detected, and you can see some of them are Earth-like, some of them are super Earth-sized, some of them are the size of Neptune, etc. But when you do any kind of, when you take data, not only do you have to know your instrument, you have to really think carefully about the plan under which you're taking the data. Are there biases? Have you chosen areas to look that already give you a bias that you're only going to see, say, for example, in something like this, you're only using high velocity stars or very bright stars? Are you complete? Have you actually looked at is your plan allowing you to see all aspects of the question you're trying to ask? Are you going to be polluted by outliers? Are there going to be, and how are you going to deal with those? Are there going to be cases in your data that really, you think you should be able to throw out because there was something unusual about them? All of these things have to be sort of thought about before you even take the data. And then once you actually get the data, and you think that you've analyzed it and you have a conclusion, first of all, your analysis plan has got to be, now that you actually have the data, what actually did you do with the data? Did you clean your data? Did you process your data? All of those things you're going to get, people are going to ask you detailed questions are. And then here I'm showing, this is the only equation I'm going to show you. But this is for the biosignatures. You know, if we make a claim that I have found evidence for life on another planet, then there's this whole detailed way that we've got to, there's so many ways to be fooled in that, you know, people are using what are called Bayesian frameworks now for understanding all the different ways that to evaluate. You want to make the claim, you want to know the probability that given some data that you've had and the context in which that data was taken, whether or not you found life, right? And it turns out it's not that simple. It's not going to ever be so simple that like, oh, look, I found this data, therefore I found life. You know, it's a very, very subtle connection in terms of because you're going to have to think about probabilities, etc. The probabilities about whether or not you're right, and it turns out you've got to analyze that as well. So one really nice example that you guys might want to look at is this study, the community report from the Biosignatures Standards of Evidence workshop. I highly recommend this because, you know, a bunch of people got together and what they tried to do is say like, all right, before anybody makes a claim that they have found a biosignature, either from, you know, like a Mars lander or from an exoplanet, what questions should they ask? What standards should they meet before they were willing to go out and make a claim? And you can see here, like question number 1, have you detected an authentic signal? Have you authenticated your signal, right? And is it statistically significant? Is there enough signal to noise ratio? Have you ruled out artifacts from the measurement, right? From the actual equipment itself, pre-processing and or from analysis that might mimic a real signal? Question 2, have you adequately identified the signal? Have you adequately ruled out other potential sources for the signal? For example, have you ruled out contamination in the environment or some other real phenomena that could produce a similar signal? Question 3, are there, in this case, you know, since we're looking for life, are there abiotic sources for your detection? Is it likely that there is a current or past environmental process other than life that could produce this signal? All right, so I won't go through this anymore, but this is a nice thing that, you know, you guys might want to look at. And then what it's going to give you is, well, in the end, you're going to get a grid like one of these that sort of tells you the link between your evidence, how good your evidence is, and how much your evidence is in agreement with your claim, right? And so you go everywhere from low agreement, limited evidence, to high agreement, robust evidence, right? So this is what we mean by standards of evidence. Okay. So what is needed for UAP science? Well, this is from the book. Don't laugh, but look up, look down, look all around, right? And so I'll explain this in a minute. But, you know, this is already a strategy that people NASA's UAP team did and the Galileo project is using. And so any real scientific effort, I think, to moving forward to do UAP science is going to have to or get data that could study UAPs as in a scientific manner is going to have to do this. And so look up, you know, actually what I did is when I was making these slides, I looked at the Meteor folks, because that's right, that what the Meteor folks are doing is a great example of what is required for, you know, understanding, for categorizing UAPs and beginning to have some kind of agnostic data gathering so that you could at least begin to sort of characterize them. So looking up means a network of ground stations, right? And so these folks are, you can see this is one from an Australian program. And, you know, there's really this question of knowing your plan, right? Okay, so you've got to build the detectors, and the question of what wavelengths you're going to use. Are you going to use both sound and electromagnetic waves? Are you going to also use what kinds of electromagnetic waves? Radar, visual, infrared. And then this also comes to the idea of, so that's, you know, your instruments, but then also your plan. Where are you going to put them, right? Are you going to uniformly distribute them across the United States? Well, that means pretty sparse coverage. Are you going to, you know, cluster them around, say, places where military jets fly? How's the military going to feel about you doing that? Okay, so that's the looking up part. The looking down part this is what the NASA panel was about. Can you use satellites? Can you either put satellites up or use existing satellites to try and characterize, when a UAP, to just sort of do an all-sky survey and try and see when, can you catch any UAPs and characterize them? Again, here the problem is satellites are moving all the time. And so, you know, do you have enough satellites to actually do this? And so the same questions again about what wavelengths, et cetera, are you going to look in. And then look all around. I would say this, for what I mean is, since pilots so often are the ones who are involved in this, maybe you have something, every airplane, commercial airplane and military plane as well, could have a little red button on it that, a pilot triggers when something is seen that is anomalous. And that could do two things. Maybe there's equipment on every plane. Sensors are so easy to put on now, that started the cameras rolling, or it actually activated the both satellite and ground stations. So this is clearly the way. I'm not saying anything that other people haven't already thought in a lot more detail than I have, and I'm sure this is what you guys are thinking about. So you can imagine this is what is going to be required, but it's a difficult thing, right? And it's difficult because of one level, because of data pipelines. So this is a screenshot from a paper on high energy physics, where their detectors are recording squizillions of events, and most of those events are not important, right? And so it's got first on the fly. You can't take that much data. So you've got on the fly, you've got to decide like, nope, we're getting rid of those. Those aren't important. And then the ones you keep, now these are being passed through a filter. You're going to try and, process them, reconstruct them. And then eventually, so there's this whole long process that eventually spits stuff out into the place where again, this is where know your data, right? Now you have data, and now what are you going to do with it? So all of this is, well, up here is knowing your instruments. Here is knowing your data, and then down to here is your analysis, which is going to lead to results. And there's going to be enormous challenges because of the all sky nature of looking for UAPs. You don't know when they're going to show up. You don't know, what a priori when. You don't know when and where they're going to show up. So you're going to have to take a lot of data, and how you're going to sort through it all. All right, so that's the way you're going to do it. Obviously, it's going to cost a lot of money. And so, there's the funding question, which I certainly understand why you guys would be frustrated by. But I got to tell you, as an astronomer, I'm going to tell you, like, oh, no poaching money from, the existing science budget for this. And that may make you upset, but I'm going to tell you why straight away. We can barely do what we need to do. Like the questions that we're asking, that we're really interested in, we can barely get the money to do that. Like, for example, the Chandra Space Observatory, which is a beautiful X-ray observatory, which has been in orbit doing great work for decades. NASA was going to turn it off because they basically didn't have the money to continue to fund this fully operational space observatory because they had to fund other things. Right. And so this is the challenge. The only place this kind of science gets funded is by NASA or the NSF. And, it's chump change in the budget. So, as a scientist who would say like, yeah, it would be good to, I'm someone who would say, sure, let's go ahead and do this. But like, there is no money in the space science budget that's available to do this. So the challenge here for you guys is to find, where's this funding going to come? One could say like, look, for the price of a stealth bomber, you could probably go a long way. So, that's the most obvious way, is to ask the military, is there funding there? But as we're going to see, there's challenges with that as well. Okay, let me see where I'm at here. I'm actually not going to cover this because I was going to talk a little bit, just because it's kind of fun, about the UAP physics, right? If this stuff was connected actually to UAP, if UAPs were actually connected to exotechnologies, what would you have to think about the physics of this? Because one thing I want to absolutely say, if people want to make the claim that UAPs are somehow connected to exotechnologies, then you can't just wave away. When somebody says like, well, there's no existing technology that could do this, like say for example interstellar travel, I don't think you can just wave away and say, oh well, they've got it, they're super advanced, they know how to do this, for a bunch of different reasons. And so there's got to be some effort to actually think about what technologies, what are the physics, even though of course there's more to be learned about the universe. We also know quite a bit, and the important thing to understand is any new physics that we come to understand gets laid up on top of the physics we do understand, right? When general relativity came, Einstein's general relativity, it's not like we said to Newton, "You're done, we're never using you again." Newton had to be shown to be the limiting case at low velocities and low masses of this new theory called relativity. So that's always the challenge. So the reason why there's this claim that people make that UAPs are related to exotechnology because they can do amazing things. They must be coming from advanced civilizations. They can disappear at will. They can do crazy things like make right-hand turns at not Mach 5. That should be Mach 50. Excuse me. Now I won't go through this unless maybe we'll have time for it later on. But I just thought to sort of think about what kinds of technologies we can imagine, what kind of physics we can imagine for interstellar travel, just because the distances across the stars are so insanely vast. As a technosignature researcher, I am somewhat skeptical about whether or not interstellar travel is any civilization is regularly going to be able to do that. That it may be very limited, it may be very difficult, and that has huge consequences for technosignatures as well. It may be very difficult to have interstellar civilizations of any kind, depending on what's possible physics-wise. So, I was going to talk about generation ships and hypersleep and general relativity-based solutions like warp drives and wormholes and quantum weirdness, but I'm not going to do that. And cloaking and right-hand turns at Mach 50, but I want to stop soon. But I do want to talk a little bit more about this idea of future physics, right? This idea that the things we're seeing with UAPs are advanced, super advanced technology. Because, of course, any civilization that lasts longer than we do will, of course, eventually find warp drives and quantum transportation devices, etc. And I want to be careful about this. Is something as I've thought about the progress of technology in human civilizations, I think has some warning signs in it. So this here is one of my favorite video games. It is Assassin's Creed. It's the first Assassin's Creed, and this one takes place in the Crusades, right? And you'll notice they're fighting with swords. Stab, 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 hack, hack, hack. Now, the next Assassin's Creed 2, took place like 300 years later in the Renaissance, approximately 300 years later. And what's amazing when I watched this was like, it's, a couple of centuries later, and we're like stab, 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 hack, hack, hack. We're still using swords. You got to go further up to Assassin's Creed 970, whichever the version they're on now, where you actually start getting guns and other technologies. And actually, if you look at human civilization, we go through long periods where there is no acceleration in technology, or it's a slow, steady creep. This idea that technology always accelerates, that there's always, that of course we're going to find warp drives, we'll solve that problem, I think is an artifact of the fact that we live in what is called the Great Acceleration. So this is a plot of everything from carbon emissions to GDP to paper productions, species extinctions, motor vehicles from 1750 to 2000. And what you see is that it's only been the last 100 years or so that humanity's been part of this incredible acceleration in technological capacities. And so there's this idea, it's a cognitive bias, right? That what's happening now will just continue forever into the future. And there's absolutely no guarantee of that. In fact, one thing to look at is air travel, right? What's the fastest that any average human being could travel in 1960, right? Which is 60 years ago. And it was about 500 miles an hour on a jet plane. And what's the fastest that an average human being can travel right now? It's about 500 miles on a jet plane. Because really, as we've made enormous progress on other kinds of technology, like digital technologies, but when it comes to moving mass from one place to the other, we haven't really made any, we've gotten more efficient, but we haven't pushed by 3 orders of magnitude our ability to move a chunk of mass, large macroscopic chunk of mass from one place to the other. So we have to be wary when we think about UAPs as exotechnology and attributing miraculous technological capacities to exocivilizations, because the idea that any civilizations that are more advanced than us will have solved every physical problem you could possibly imagine. Nature may just impose some limits on any civilization that may be difficult to overcome. All right, last thing. I will just spend a couple minutes on this. So this is a question I have for you guys, which is when it comes to UAPs and UFOs, and the question of who cares, right? So if a scientific study of UFOs and UAPs demonstrates no evidence for exotechnology, then who would care, right? Because really, so much of our interest in this, so much of the way that the public has been engaged with this is because it's the link to aliens and all the things, all the sociology that goes along with the idea of alien civilizations. So, who would care? Well, certainly for air safety, for sure, because pilots, pilots care about it if there's an air safety issue. The military would care about this for sure. But, I want to note that there's some real issues about this for the military, which is that, if there really is, if UAPs are associated with a peer state adversary, and I got that term when I wrote in 2021, I wrote a New York Times piece on UAPs, skeptical. And I was digging into the literature, and I wanted to see what military people, especially the ESIG, the electronic signal intelligence people, were interested in. And that's where I came out with this idea of peer state adversaries: Russia, China, Iran. If this is an issue linked to them using drones to spoof radars and etc., which is, the U.S. has done. There's Project Palladium, where, throughout the 50s and 60s, the U.S. was purposely figuring out how to project images and signals into Russian radar to learn about what its capacities were, and just in general to confuse it. So this is paper. Whoops, excuse me. This paper down here: Stealth, Countermeasures, and ELINT. So there's this issue for the military who's like, let's say UAPs actually come down to the use of not even sophisticated drones for spoofing military engagements. Would you want the military to tell everybody they knew that, right? I mean, one of the first, rules of the military is don't let your enemy know what you know. So if it turns out that UAPs really were, related to a peer state adversary, do you want the military to stand up and say, oh, we know that Iran is trying to do this to us, right? Because you don't want your adversary to know what you know about stuff like this. So it leads to all kinds of sort of issues. So I guess that's a question for you guys, from your perspective, if it doesn't have any link, if that turns out, now we don't know, that's what the agnostic is, but if it doesn't have any link to exotechnologies, then does some of the whole juice for the case get sort of exhausted a little bit? All right, so I'm not going to cover this. I was just going to tell you a little bit about what I'm excited about, right? The reason I don't do UAPs is because life is short, and I want to study what I want to study. I want to study what I think is going to lead me to results, and that's biosignatures and atmospheric character, biosignatures and technosignatures. But I'm going to end there because I've already gone over. Okay, so what are my conclusions? An open, transparent, agnostic scientific study of UAPs would be a good thing. Nothing today comes close to showing any links between UAPs and exotechnology. And everything depends on those standards of evidence. So, and also astrobiology rocks in general. So I'll end with my little thing of my book here, and then I'll be happy to take questions. And thank you for your time.
Thanks, Adam. Can you hear me okay? Great. Yeah, thank you so much. I mean, yeah, obviously way too much stuff to talk about in the limited time we have available to us. I just had, maybe just a few opening questions, and then we'll quickly go back. So, in transitioning, let's call it a transition from, say, this sort of cul-de-sac of cold case chases, which tends to be, unfortunately, the typical fare in what is called ufology. As we make that transition, into this more prepared, preordained, pre-established scientific, system of observation, experimentation, and so on, that's focused on the UAP question, do you think that nonetheless right? Now shifting sort of perspectives a bit, do you think that even as we shift towards, this more rigorous observational science, which could yield the data on which to reason to better conclusions, do you think that nonetheless that this literature, what the Galileo Project has called the gray literature, do you think, and this is the argument in their very key paper in 2023, do you think that nonetheless, just like you see in medicine, let's call it the folk descriptions, the folk reports of these crazy stuff happening and people seeing, these objects doing these bizarre things, do you think that nonetheless can aid in the science in some way?
I don't think it can aid in the science. It can spur, you can use it, and especially now with the modern pilot reports, to say like there should be more. But I don't think it's going to aid very much, because I think it's first of all, you don't have, like, unlike folk medicine, you've got thousands of years of folk medicine and indigenous, knowledge. Here, you've got 40 years or 50 years, so contaminated by other things that I think it's very difficult for it to. This is just my feeling. Just to finish that thought, I think it's going to be very difficult to use that for anything other than saying, like, look, we do have a small number of cases, like in the McDonald's paper, where people went back and tried to do a better job, and there was stuff there that is resistant to an easy explanation. But that's about as far as it's going to go without the new data. It's just, as you said, I really like the way you say it, the cold case thing. It's a cold case,
Yeah. So, and this is another question, kind of segues into what I wanted to kind of get you to talk a little bit more about, was that you were, and in fact, this is what inspired me personally as well. The reading of eventually I came around to reading MacDonald. I was trained in philosophy of science, so I really care about the thinking process here and reasoning with science to conclusions. But in that paper, it was kind of it was a wake-up call, like to a reassessment of something that had been seemingly concluded. But in fact, when you kind of do a little bit of a deeper dive and be really careful about the process of thinking and analysis and processing of data, right, that MacDonald comes to somewhat different conclusions. But do you think that in that paper, in some sense, he is kind of showing kind of the use of what you might call the sort of the folk reports, or would you consider, like, some of the stuff that he was looking at, like some of those cases that he was reassessing from Blue Book, do they not count as that kind of a folk reporting, or how do you see that?
I see it. What this is the problem with, again, as you say, they're cold cases that you can't go back to and you can't really do anything with, because, like, say the case, the one I used in the book with the Navy plane over Louisiana that has the bright light that shows in front of it, and you hear it's like, oh, we saw it on the radar. The guy on the ground station saw it on the radar. And, it's like, oh my God, I read that and the hairs on the back of my, it's a ghost story, right? That's the problem. Yeah. It's a ghost story where, like, somebody you trust, somebody you really know and you like them, and they said, oh my God, last week I rented this house, and, and there was, and you're like, wow, okay, I have no reason to doubt you, but, it's a little, So we don't have the actual radar data. We have accounts. And I just don't think there's much you're ever going to get with those accounts. So without actual data that we control ourselves, these will remain ghost stories. And so they get put in the box of, like, I don't know what to do with that, but I'm certainly not going to be able to use it to make a claim that, like, we're being visited by, advanced.
I mean, that's right. So, I mean, when we want to make an extraordinary claim like that, surely we have to have the evidence that justifies that. And as you rightly point out, obviously, in your standards of evidence piece, right, that requires a whole bunch of preliminary work. You have to understand your instruments. They have to be deployed properly. You have to have a system established. But, the problem is a sort of a catch-22, right? you need the folk story. You know, this is sort of, I think, part of McDonald's point, and a lot of, you know, in Galileo Project, in a sense, their paper sort of articulates this. The literature does function in the sense of it gives you some kind of initial sense that there's something weird here. There's, you know, weird radar returns, sometimes, you know, corroborated by witness testimony, you know, like the Nimitz case famously, that sort of is indicative of a range of phenomena. And it sort of gives you a clue as to like what the instruments ought to be, that if you had controls set up and you understood them and you had a pipeline in place and a research program prepared for that kind of a stuff, then we would have the system in which that data could be finally produced, and then we could come to more definitive conclusions. So in other words, like I like to put it, you know, a lot of these cold cases provide you with suggestive but not definitive evidence. It's sort of evidence that might actually be convincing, not in a strict standard, you know, not in a strict court of science, as it were, but kind of like, you know, in a legal context that would sort of establish that there was a real phenomenon to some of these things, and there's something strange happening. But the nature and origins of that, well, we can't comment on that because we don't have the system in place that could answer that question. So I'm going to open it up, excuse me, to some of the audience questions. So one of our colleagues, Beatrice, please give you the first question.
I completely agree with you about that we need to really follow the methods of science. In fact, I'm also working on such a paper right now, writing about why we need to use how and why we need to use the methods of science. I really liked how you outlined it from know your instruments, know your plan, know your data. But one thing I think is missing, and I think there's also a contradiction when you talk about that we have to be agnostic. And that is that if you're agnostic, it means you have no hypothesis. And also, when you do these methods of science, you need a hypothesis in the beginning. And a hypothesis, like any others, is that there's ET. And if we go completely agnostically and only collect the data, let's be honest, UAP is not a hypothesis per se. It's a dumping category. And just like trying to figure out what it is when it could be 99% of these are mundane explanations that are uninteresting to us, it's very difficult to work with something. You cannot build a hypothesis just saying that it's a UAP, since it's a dumping category. But an ET artifact or an ET spaceship is not a dumping category. That's something that's a very concrete thing you can work with. You can build a very concrete hypothesis based on the ET. So I would say we cannot work agnostically with UAPs. We would have to build it down to dissect the UAP question to the most interesting and most relevant problems that can progress basic science. Because honestly, we don't want to know what is a UAP if it is a secret military missile. I don't want to know it. I only want to know if it can advance basic science. Anyways, just some comments from me. I was thinking when looking through your outline.
Yeah. Yeah, well, I do think there is a way. I understand what you're saying, right? And so, you know, very much there's this, hypothesis, making hypotheses, and then, you know, the whole idea with statisticals, right? The null hypothesis, etc. So I see what you're saying, but I do think that there's a part of science in the beginning that often is agnostic, even if like the formally agnostic, right? I mean, so I'm going to take an example of the HR diagram in astronomy, right? There was a way in which there was this new technique for doing spectroscopic observations of stars, taking spectra of stars, and then categorizing those stars based on their spectra, right? So the whole that whole process in the turn of the century, which was just like, you know, gathering a large, so I call it butterfly collecting, right? You first go out, you just find a lot of butterflies, and then you see like, oh, there are some butterflies that have large blue wings, and there's some butterflies that have small green. And then from that, you begin to try and put together a hypothesis of, you know, who's connected to what's the organization of that. And I think for UAPs, because I actually think it's very important because of the history of this, to come into this without the hypothesis and to do just the butterfly collecting. Let's just get the data. Let's just get the data. You know, all the different wavelengths, all the different time, time series, and see and parse it. Start parsing the data into categories, and then we'll be in a better place to actually formulate hypotheses. But in particular, I would say for UAP, so I would say that in general, with science, there can be, especially when the field is new, there's a period of just data collection and data characterization, and then there's and then patterns and hypotheses begin to emerge. And I'm actually going to say that because of UAP's history with the association with UFOs and with alien technologies, and that there's really hasn't been anything definitive that makes that link. You actually want to be very careful in this case to not start with that link, but to start stepping back. And that's why I asked that question. Like, if it turns out that you do that and you find that there's nothing here that's moving at Mach 50 and took a right-hand turn, then what happens to the field?
Beatrice, do you want to follow up with that, or?
Well, I think we can agree to disagree on how to
Sure.
work with UAPs. We
Right.
can keep on the discussion offline. Maybe.
Yeah. So that's just what my feeling is. And, part of this is that I've been a popular, I've been a science popularizer. And so it's with the public and trying to work with the public on this issue. I just really feel that in this case, because like I said, I think this is part of science. There's definitely, I would argue that there's parts of science that is data collection. That in this issue, and it's an interesting question to think about. I think this issue really demands kind of agnosticism.
I just get an impression of that people have been doing data collection for 80 years and they are stuck in all kind of report centrals and so on, and it hasn't led to nowhere. And that's why I personally think that we should be working very hypothesis-based, which is why we also created, we actually have been working with, let's say, the Vasco project. We are doing concrete hypothesis tests. We're looking for little glints along a line, and surprise, we do find them in the 50s. Surprise, surprise, a 4 sigma detection, of course. But it's, again, it shouldn't be there, so we can ignore that. But we also build the ExoPro project, built on this hypothesis of that we are looking for reflections or emissions from artificial objects. And we are starting to work with these things, but they are very concrete, because I think it's when you work with a very concrete hypothesis, it's easier to know your instrument, it's easier to know your plan, it's easier to control for biases, for if you have completeness of the survey, and to develop very careful frameworks in some ways. At least I prefer to go that direction, and I know many others don't agree. I think we work differently from many other projects in that sense. But I somehow feel that one of the big challenges, which I think Mike is going to be helping us with, is to really identify what are the most interesting and relevant problems for fundamental science that we could learn from the UAPs. Because I think if we can identify the 10 most important questions, hypotheses of what it could be, and each one enters, if astronomers enter on the ET connection, meteorologists maybe will go to explore new beautiful ball lightnings, then maybe we can really do huge progress by concentrating our efforts. That's more my thinking, but I appreciate how you look at it also. I understand Galaxy Zoo also works like that, so it's two very different ways of watching science.
Yeah, no, and that's absolutely, and it's funny, it's interesting when you look at science, like, with things like the big survey projects, right? I mean, the survey projects start out with, there's definitely questions they're interested in, right? Like pan stars or whatever. But there's also this sense of like, well, we're just, we're collecting data, and we understand what our collection, what the data is in our collection, but then also that the data is going to be available in ways for lots of people to do lots of things with.
So if I can just jump in before I switch to perhaps what'll have to be our final question from one of our other colleagues, a political theorist, is I see, Beatrice and Adam, I see there is a lot, I see there to be differences, obviously, but they seem to be complementary, in a way. I mean, the Adams, I think, point, is the collection of data and then hypothesizing on the basis of that when the data suggests that something needs to be explained. Like, if you are getting data that's rigorously showing to you, in ways in which we understand the instruments giving us this indication that objects are moving at what the cold cases indicate, which is, Mach 30, 40, and 50 in this kind of vicinity, when you get data that's sound, that shows you that's anomalous, right? I mean, and that requires you to introduce
Right.
a hypothesis to account for the data. So I think Adam's point is, when you have the collection of that data, then you have something that could call for an explanation, and that's a classic sort of science approach. But then, you know, in Beatrice's, you're offering, you know, you're saying, well, let's begin with a notion of what we want to sort of look for, and then we're going to see if that evidence is there. Now, interestingly, isn't that kind of, Adam, what you're doing in astrobiology? You want to look for life. It's a hypothesis that there is life in the universe, and you want to figure out, well, if there is life elsewhere, you begin with that as a hypothesis that it's elsewhere in the universe, reasonable. And you sort of argue, you know, why that might be the case. You know, you look at the proliferation of planets and the various kinds of atmospheres they may have, and so on, the habitable zone, et cetera. And then you set up standards of evidence with respect to that hypothesis, and then you go and look for it. So in a sense, you know, so Beatrice's methodology is, you know, it fits into a broader picture of, I guess, different kinds of approaches in science. One is hypothesis driven and heavy on the front end, with you know, something you're searching for because you have some reason to believe that it exists. It's part of nature. And then there's the other sort, in which you're gathering interesting observations, and you're putting forth hypotheses to account for that. So I think there's a beautiful compatibility. If I could just ask a question from our colleague Michael Uhal. He's a political theorist. He wanted to ask you, Adam, what you think is the cause of the so-called giggle factor regarding aliens. And this is something, you know, Sagan, you guys have all had a battle in SETI, right? I mean, for decades. Note that I'm not, so it's not unique to UFOs, right? So not that I'm asking, he says, about skepticism per se, like you, Michael says, I'm a strong agnostic, but something I've started to notice as I do my own work in conceptual engineering and philosophical anthropology is just how weirdly strong is the disincentive to talk about, quote, aliens at all, to think through the numerous conceptual and philosophical issues that ideas of the alien give rise to, right? This makes it harder to think about these issues as an academic without simply being dismissed or mocked. Why is this? Giggles and smirks do not strike me, he continues, as useful social tools for the pursuit of knowledge. I think this was something noted by the NASA independent study team. For the pursuit of knowledge, right? These are not useful tools. Performative incredulity carries very little epistemic weight. Would you like to comment, Adam? Thank you.
Yeah, it's I like the way you put that. You know, it's a really interesting, really interesting question about, you know, forget about UFOs or SETI, just in general, why has there been this sort of thing about that life elsewhere on another celestial body sort of can drive this, and, you know, which is interesting because the question is as old as the hills, right? I mean, I have a slide I didn't show, but, you know, Democritus and Aristotle are arguing about this, you know, or Aristotle's like Earth is the only world. You know, there's only one Earth. Democritus, there's lots of Earths. You know, Giordano Bruno gets burned at the stake for this. So, yeah, what exactly is going on that in the modern era, it's met with its particular smirky, you know, and I think that has to do with a number of things that are, you know, that are sort of sociological. One is the, you know, media, right? That, you know, very quickly, you know, it's that this question emerges, and I, you know, covered this in the book. It's that critical era from 1950 to 1960. Where, you know, the first UFO report's 1947, the first one that really generates a lot of interest. It's the Cold War. There are a particular set of, you know, of concerns about, you know, annihilation, about rapid progress in technology that are occurring when the first steps where both UFOs show up and the first steps towards astrobiology. In the book, I identified Fermi paradox. And then by the end of the 60s, Project Ozma, the first SETI search. And then you're getting all the rocket technology, Sputnik, etc. So there's a bunch of concerns and anxieties that then Hollywood, that great maker of myths, steps into and starts, churning out these images, these visions of the alien, which are, mostly ridiculous. And I think, and of course, they're tapping into anxiety. Normal human anxiety is about death and life and sex, and because like how many of these things have, what is it? Mars wants women, right? I mean, there's just so much human. The alien is always a reflection of the human. Yeah. So I think just in the era, the moment it appeared, happened to be an era where the smirkiness, the laughter, was particularly, there were things that happened that triggered that. And I think what's interesting now, because of climate change, because of what's happening in astrobiology, the discovery of exoplanets, that actually we're beginning to maybe pass through that, that certainly technosignatures I'm watching finally get some biosignatures have been science for 10, 15 years. They were accepted. Technosignatures are now being accepted. Maybe this will happen with the UAPs, that people we don't need that anymore. We recognize we live on a planet among zillions of planets. And life may be possible in lots of different places. And the idea of, we may be coming to a time with a different recognition of what planetarity, I love that word, that may be what the new era is, the new political economy is going to be based in.
Yeah. And we can't forget that, in many ways, science has frequently disabused us, right, of our sort of anthropocentric notions, and this is something that perhaps is on the horizon, with perhaps first astrobiology. I mean, there may be right. I mean, we have to think really, really widely. There may be forms of the alien that simply do not conform, right, to our projections and the entire mythologies that have been created around the figure of the alien. So in some sense, science is alienating to our concepts of life. And we have to be prepared to receive that at a philosophical level, right? So, ironically, as we push forward, I think in nature teaches us, how bizarre things could be. So we have to, on the one hand, we want to begin with what we know. And I think that's where we begin with the hypothesis of life and the organic structures of life that we understand on Earth. But then, of course, we have to be sensitive to being humbled that there may be forms of life that may be quite alien, and that might renovate and renew and even transform our science in radical ways that we might not have expected, right? And that sort of gets me to another point, but about the continuity of science. You mentioned Newton, and I sort of thought as you were saying that, yes, Adam, but we don't have much. We only have 400 years after the radical transition from Aristotle to an entirely different cosmos in the Newtonian world. And I think it's an interesting philosophical question, the extent to which we have let go of Newton, even though formally you recover it as a limiting case, as you rightly point out. With quantum theory, it gets a little bit more difficult, but this is the question. We don't have many examples of that sort of radical shift from Aristotle, say, to the Newtonian paradigm, which we're still in some sense within that orbit. So I would ask you, how radical, right, can a scientific shift be? Could it even be the case that this principle of continuity, of recovering that which we have determined to be the case, in a certain phenomenological, regime in which our experiments give us predictions and so on for particles and our, and so on. Is it, how radical can we imagine science to change? I just wanted to get you to sort of, I know this is a little bit of a larger question, but
yeah. Well, we have a new book, myself, Marcelo Gleiser, who's a particle physicist or a high energy theorist, or just a theoretical physicist, and philosopher Evan Thompson have a new book called The Blind Spot: Why Science Cannot Ignore Human Experience, where we're arguing that we're at the edge of a pretty profound transformation of the kinds of the metaphysics, the ontologies that science has been working with. It's not really, and we're not even saying it's science. Science is a method. Science is fine as a method. It's more this metaphysics that's gotten glued on to science, reductionism, objective ontologies, this view of that science gives us the view of the God's eye view, etc. So this is a pretty deep thick book of philosophy. But I would argue that, look, I mean, that the transformation we're already in kind of a paradigmatic transformation, which is going to have a huge effect on our understanding of life, because actually life is central to the whole thing. But I do think, I guess I would push back that, science is conservative in the sense of it's that you have to recover the results from beforehand. You can throw away what we threw away with Newton was a standard
absolute
time.
space and time.
Space,
right,
exactly. Objective time. We got rid of that, but of course we had to keep F equals ma, because that's been proven 10 trillion times. So what you rest on is the empirical results. Right. And the mathematical formulations. But what you may do, and this is like Thomas Kuhn, right? Is you're going to get rid of the metaphysical meaning of some of those terms. So you have to keep what works from experiment already, but you may change how you understand what's happening in that experiment.
Unless the ontology is somehow intrinsically related to the formal representation of the results. Yeah.
Think about that one.
This is Anyway, Adam, thank you so much. I mean, there's so much to talk about. I mean, there's so much you gave us that we can sink our teeth in for hours. Your slides were wonderful. Thank you so much for your care about the science of these phenomena. I know we don't all agree on everything. I found personally a lot of continuity and connection here. In your talk, I'm really honored that you spent your time with us. For you it's the morning, for me this evening. I hope that we stay in contact. Please, the Society is also a resource for you and the general community, and trying to bring scientists together with other UAP researchers to push this forward, to go beyond the cold cases, right? To think hard about the rigorous science that needs to be the basis on which we can make some kind of progress. So thank you so much, Adam. Thank you everybody for joining us. Thanks from the Society for UAP Studies. Again, have a wonderful afternoon, morning, evening, wherever you are in the world. Thank you so much. I'll bring our lecture to a conclusion. Thank you. Good night.
Thank you, everybody. Take care. Have a good day.
Thank you.
Or night.
Thank you.